So here we are with the last example for chapter 6. It is from section 6.4, modeling data with a curve of best fit. I've chosen question number 8 as our example because it does cover everything that you need to know for the section. So the question is in 4 parts. The first part asks us to plot the data as a scatter plot and then describe the trend. So the only tricky thing about this is that time is actually the independent variable, so I want it to be x, and therefore is L1. And volume is dependent on the time, so I'm going to let this be the y, and so it will be L2. So when you enter the data in your calculator, it will be a little bit crisscross, but if you are diligent, you should be able to manage. Let's go back to our calculator here. Okay, there we go. Press the stat button, edit, and once again I've entered the data already just to save a little bit of time. Again, please be very careful when you enter your data just so you don't make any silly mistakes. Okay, so once again, we're going to set up our window. Now this time, I've chosen the numbers a little bit differently. The minimum of the time, x, will be 0, and the maximum, I set it to be 70, although that's way past 40. But I expect the volume to go down slower and slower over time. So I don't know exactly when it's going to bottom out. So I'm going to choose 70 just to be safe. On the other hand, the minimum volume is certainly going to be 0, and the volume max can be 250 or something along those lines. So I guess I can change this to 250 and it should be okay. And then after you set up your window, you do want to go to stat plot, make sure that this is on. Okay. Unlike the previous example, the plot number 2 is going to be off this time because we just have the volume and the time. Okay, so that's on. So let's graph and see what we get. Okay, so we do get a trend that goes downwards. The volume is going to decrease over time, and it looks kind of a straight line, but it's actually more of a parabolic curve. So it's actually going to go like this. So if when you describe the trend, you can say that so we can have the down slope is parabolic, or something along those lines. Parabolic. I think that's how it's spelled. And then once again, you do want to take a screenshot here just to see picture. So let's do that. Okay, it's a little bit squished for some reason. Let's fix that. Okay, looks pretty good. There we go. So that's the first part. The second part is to determine the equation of quadratic regression. Sorry about that. So the only difference between the previous example of the linear regression and this one is that when you go to stat calculate, instead of calculating linear regression, you will calculate quadratic regression, which is number 5. But everything else is the same. So you go L1, comma, L2. Let's enter. And you know that because this is quadratic, instead of having 2 different numbers, you have actually A, B, and C, so 3 of those. So let's write those down. Again, we're just going to keep it to 3 decimal places. Just make things nice and simple. So 0. I believe is 0.65. Yeah. 0.65. X squared minus 7.651 x, and then plus 224.885. Okay, so that will be our equation of the quadratic regression function that models the data. So the next 2 parts is something new. So I'm going to do this in a different color. Part C. It asks for the time when the tank is half full. So do recall that the volume is represented by the y values. So we're looking for x value when the volume is half. So y equals 225 over 2, because that will be the half volume. Half full. So unfortunately, because we are given the y value, things will be a little bit different this time. Okay, the first thing we're going to do is still want to graph this quadratic function, so I'm going to go with y equals, and then I'll go vars number 5, which is statistics. I'm going to go over to the equation, and I want the regression equation, which this time around will be quadratic, so I should get some kind of a parabola. It will come back up the other side. You can see a little bit there, but it's not as obvious. So it does go through all of the points, which is good. And what you're going to have to do here is you have to go to y2, and you have to find out what 225 divided by 2 is. Let's see what that is. 225 divided by 2 is equal to 112.5 liters. Okay. So I'm going to let y2 equal to exactly that, 112.5. And when I graph, there will be a separate line there. So if I'm looking for the time when the volume is half full, I'm looking for this intersection there. I'm looking for the x value at that point. So how do I do that? Well, I go second, calculate. I'll go to the fifth option, which is intersect. And then first curve is the parabola. Second curve is the line. Do you want to guess? Yes, you do. And it will end up right there. So that will be 17.2 minutes. So you can say x equals 17.200 because it's supposed to be 3 decimal places minutes. And that will be sufficient. Now the last part, it asks for when the volume is going to be 0, determine the time when the tank will be empty. So it's the same thing, but instead of y equals 112.5, we're looking for x value when y is equal to 0. Because when the tank is empty, the volume will be 0. Okay, so I just need to change y2 to 0. Delete all those. Graph that again. And you will not be able to see the second line at the bottom, but that's okay, because it is there. So you can go second, calculate, intersect, and then the first line, the second curve, which says y2 equals 0, guess yes, and then you will find the first one. So it will be 56.220 minutes. So it's 56.220 minutes. Okay. So in essence, when you're given the y value, you have to plot both y1 and y2 and find the intersect. If you're given the x value and you're looking for the y value, you can just go to second, calculate, and input your number there. Okay. And the only difference between a quadratic regression and a cubic regression is that when you, after your data, enter your data, and you've done all those things, when you go to calculate, right, instead of going to quadratic regression, you go to cubic regression. And that's the only difference. So we'll see we have time before Monday to do one more example, but for now, we're going to end it there, and hopefully that will help you prepare for your tests when you have to use a graphing calculator.